Okay guys, welcome back to our board work here. So I guess it's been a while since we had our magic board over here. So let's try to continue our lessons on analytic geometry. So if you would remember, the last discussion was on distance between a point and a line. So this time we'll try to solve some problems on how to compute the distance between two lines, so parallel lines in particular. So to better understand the concept behind the distance between two lines, so let's try to have these examples, okay? So the first one is we are asked to find the distance between the line x is equals to 4. So we have a line which is x is equal to 4 and another line which is x is equal to negative 2. So what will be the distance between these two lines? So if you will try to graph these two lines, so x is equals to 4, that means 1, 2, 3, 4. So this is x equals to 4. Okay, sorry. And we have here x is equals to negative 2. So x equals to negative 2. So if I try to draw a line, so this will be x equals to 4. And then this one is x equals to negative 2. So now the distance between these two lines is that line, okay, that would connect these two lines, which is perpendicular on both lines. So that is our distance. So in this case, it's easy. So if you have drawn your lines, or if you have graphed your lines on your Cartesian or rectangular coordinate system, so you just have to count the distance between, okay, these two lines. Okay, so 1, 2, 3, 4, 5, 6. So therefore the distance here is equal to 6. That is if you have a horizontal and vertical lines. Okay, so let's try another example. So find the distance between line, so we have another line here which is line 1, which is y is equal to 6, and line 2, which is y is equal to negative 3. So again, if you'll try to graph these two lines, so 1, 2, 3, 4, 5, 6. So this is y is equals to 6. So this is y is equal to 6. And y is equals to negative 3. This one, 1, 2, 3. So this is your y, which is negative 3. So to find the distance, you just have to count, okay, the number of units that separates these two lines. So 1, 2, 3, 4, 5, 6, 7, 8. Sorry, 1, 2, 3, 4, 5, 6, 7, 8, 9. So the distance between two lines is 9. Okay. So we have another case wherein the two parallel lines are not horizontally or vertically drawn. So in other words, they are slanting. So what would be the distance between these two lines? So let's try this example. So we have these examples here wherein our lines are not vertically or horizontally drawn or graphed. So let's have this. Find the distance between the line. So these are parallel lines. The first line has an equation, line 1 has an equation y is equal to 2x plus 3. And then the second line, it has an equation which is 2x minus 3. So now we have to find the distance between two lines. So for us to better analyze the problem, so let's try to draw these lines on our Cartesian coordinate system, or rectangular coordinate system, I mean. So if I'll try to redraw, or if I'll try to graph line 1, so y is equals to 2x plus 3. So that would be, if x is 0, y is equals to 3. So 1, 2, 3. Our line 1 will intersect at y is equal to 3. And then if y is 0, x is equal to negative 3 halves. So that means that is 1.5. So somewhere here. So in this case, you have a line which is like this. Sorry for the line, but just imagine that it's a straight line. So this has an equation which is y is equal to 2x plus 3. Now the other line, it should be parallel lines since they have the same slope. Okay, so the condition here is for us to get the distance between the two lines, so the two lines must be parallel. So in order for us to check if they are parallel lines, if they have the same slope based on our equation which is y is equals to mx plus b, so wherein m here is the slope of the line. So in this case, we can say that they are parallel since the coefficient of x here are since the coefficient of x is 2. So that means they have the same slope. So the second line, if x is 0, y is equals to negative 3. So if I'll try to redraw that one, or to grab that one, sorry, we have here. And if y is 0, x is equals to 1.5. So 1, 2, so sorry. Let's space a little bit. So 1.5 here. So if I try to redraw this one, so this is the line. Okay. Sorry for so just imagine that line intersect at 0, negative 3. Okay. So what's the distance of this line? It's that line, the minimum line or the shortest distance that would connect these two lines and at the same time perpendicular on both lines. So this would be our distance. Okay? So I will try to solve this one in two solutions. So the first one is the conventional one. So I mean, it's not conventional. It's the longest solution wherein we get to go back to our basic. And the second one is using the formula. So let's try the first solution first. So the distance between this one, so if you would recall that this point is actually at 0, 3, okay? So you have a point here and a line. So on our last episode, so we discussed the distance between a point and a line. Since we already established that this line will pass or will intersect at 0, 3, okay? And if I'll get the equation of this line, which is lines, so I can use this, I can get that equation. So why are we getting that? So that we can get the intersection of this line and this line, so that we can have two lines, 2 points wherein we can get the distance between the 2 points. So let's try to solve the equation of this line that is perpendicular on both lines. So let's try. So if this one is perpendicular on that one, so we know that perpendicular lines, the slope is actually the negative reciprocal of the other line. So if this one, our line 1 has a slope of 2, so therefore that line will have a slope of negative 1/2, right? So using our slope-intercept form, so we can get the equation of this line, so which is y minus y1 is equal to mx minus x1. Okay, so we know already the slope, and then we know a point here wherein we have 0, 3. So y minus 0 is equal to negative 1/2 of x minus x1, okay, which is, this is y over y minus 3, because this is 0, 3, and then x 0. So therefore, y minus 3 is equal to negative 1/2 of your x plus 0. So y is equal to negative 1/2 of x plus 3. So in other words, this line, okay, will have an equation which is equal to negative 1/2 of x plus 3. So to get the intersection of this one, so the y of this is equal to the y of that, so we can get their intersection. So negative 1/2 of x plus 3 is equal now to 2x plus 3. So that means to get the value of x, so that will be, okay, this one will be transposed there, so that will be 5.5 of x is equal to, sorry, this is minus 3 now, because the intersection of this one, so this is minus 3, so that will be 6. So x therefore is equal to 12 over 5. So this point here will have 12 over 5, and then y will have negative 1/2 of 12 over 5, okay, plus, plus 3. So the y here is, that is negative 12 over 10 plus 3, okay. So y is equal to, that is 13 and 18 over 10, or y is equal to 9 over 5. So in other words, this line will intersect this line, our second line, at 12 over 5 and 9 over 5. Okay, so we already have established 2 points. So it's easier for us now to compute the distance, because we've learned that the distance between these 2 points, we can use our formula, which is, well, let me erase this one. So the distance now is, using our distance between 2 points formula, which is x1 minus x2, or x2 minus x1. Either way, y1 minus y2 squared. So therefore, you have the square root of, so that is, if this is our x1, so 0 minus x2 is 12 over 5 square plus, okay, we have 3 minus 9 over 5 square. So let's try to compute that one. So that is negative 12 over 5. That's 144. 144 over 25. Plus, that is 15 minus 9. That is 6. 6, that is 36 over 25. Okay? So therefore, you have distance between these two lines is 180 over 25. So I think we have a common factor here, which is 5. So d is equal to the square root of 36 over 5, or d is equal to 6 over, because the square root of 36 is 6, square root of 5. So we have to rationalize, so multiply by the square root of 5, then square root of 5. So that means we have a distance of 6 square root of 5 over 5. Okay, so if you don't have a calculator, so we can use, we can leave our answer as this. So 6 times square root of 5 over 5. Okay, so as I've said, I'll present this one in 2 solutions. So this is the first solutions. The second solutions is our using our formula. So what's the formula? If you have two parallel lines on the form ax1 plus by1 plus c is equal to 0, and then you have another line which is ax2 plus by2 plus c is equal to 0. So okay, so the formula, the distance between these two lines is actually, this is c1, c2, c2 minus c1, the absolute value. Okay, so if it's negative, you just have to get the absolute value over the square root of your a squared plus b squared. Since a and b here will be the same, since you have a parallel, or parallel lines. So therefore, applying this formula, so in this case, let's try to get this one. Let's try to rewrite this one in this form. we have y minus 2x minus 3 is equal to 0. The first line here. And then the second line is y minus 2x minus plus 3 is equal to 0. So our a value, let's establish our c2 is equal to 3. c1 is equal to negative 3. A value is equal to negative 2, and then your b value is equal to 1. Okay? So just substitute our values, plug in the values on our formula. So we have C2, 3 minus C1, which is 3, get the absolute value, over the square root of a squared, which is negative 2 squared plus 1 squared. So this will give us actually like 6 over, that is 4 plus 1 square root of 5. And then we have to rationalize, so we have square root of 5 over square root of 5. So therefore, we'll get with the same answer of 6 square root of 5 over 5. So that would be our answer. Okay? So, that's it for the meantime. So we will have more problems on analytic geometry. So next time, we'll have parabola. Till next time, guys, please don't forget first to watch, subscribe, and hit the notification bell for you to get updated on our succeeding videos. Till next time, guys. Bye-bye.